How are you all? I hope you all are fine and safe and doing good in your life. Well, welcome to Quantum Mathematics by me, that is Aman Gupta. So today what we are going to do is I have already written it over here, that is we are going to just solve a quite number of integrals. And well, let me just tell you what type of integrals we are going to solve in this video. Well, it for I think all most of the integrals falls in the category of basics, and because like don't think that basic integrals are easy to evaluate and you can evaluate it easily. It's not like that. Well, if you want to just master your calculus like integrals, you have to go through basics, and you must have a strong you should or you must have a strong in basics of yours, right? So yeah, well, I have already made some sort of videos on advanced calculus or in advanced integrals that are already uploaded on my YouTube channel, that is Quantum Mathematics. You can just check them out also. But in this video, we are going to just deal with basic integrals, and now we will be beginning with a very basic integral. I think I should begin right now. I think if you, after looking at the first or second integral, after looking at the integral, and if you know that you can do it, then you should just jump to the next integral, right? Because I will increase the level as we will just get into the video, right, from now. Okay. So yeah, the integral is x squared times e to the x cubed dx. So yeah, that is what our integral is, and most of you would say that it's very easy to evaluate. Let's just do this simplification, which it's very easy. I have just multiplied and divided by 3 in this integral. And why I did that? Because the derivative of this thing is this and that, right? Well, what I'm talking about, let x cube equals t, then 3x squared dx is dt. So our integrals becomes 1 over the times the integral. This becomes like what I'm talking about, this thing and this thing becomes dt, and this x cube is t. So we are having e to the t dt, and the integral of e to the t is just e to the t plus c, and t was 1 over 3 e to the, we have already assumed that t is equal to x cube, so x cube plus c. So that is what the answer of this integral is. Well, it's very easy, I know, but still I just want you to just practice some sort of questions. Let's move on to the second question, that says integral e to the x times 1 plus x over cos squared of x times e to the x. Well, again I would say that it's not that difficult to understand, but still if you can't, then you should just check out the derivative of this function. When you just take the derivative of x times e to the x, you have to use the chain rule, right? What chain rule says that, let me just tell you what does chain rule says. Well, chain rule, so chain rule is basically the derivative of two functions. I think they are in multiply to each other. Let's say f of x times g of x. So the chain rule says that the derivative of two functions being multiplied to each other will be sorted out to first functions times the derivative of the second function plus the derivative of first function times the second function as it is. So yeah, that's a very basic formula that you need to remember for your future calculus. So yeah, that's what we are going to use in that specific function for this. So if you take the derivative of d over dx of x times e to the x, you're gonna have x times e to the x plus x, and if you simplify it, it comes out to be sorry, this is x, sorry, this is e to the x, because the derivative of x is just 1. So if you just simplify it out after just factoring out e to the x, you're gonna have x plus 1. And if you look closely, then this is just staying at the top of that integral with along with dx. So our integral becomes the integral of e to the x times 1 plus x over cos square of x times e to the x. If I take x times e to the x equals t, then e to the x times 1 plus x dx becomes dt, as we saw here, right? So we are simplified to dt over cos square of t. That simplifies to secant square of t dt. And the integral of secant square of t is just tangent of t plus c. That simplifies to, when you just plug t equals x e to the x, so tangent of x times e to the x plus c. This is what the value of that integral is. So yeah, it's necessary to understand all these things, guys, because it's basic and you need to know. Because if we are going to just solve higher calculus or higher mathematics, we have to deal with basics in some part of, if we are solving, so we have to just master it. The third integral is e to the x times cosine of x minus sine of x. Well, if you would go with the, like, maybe you can just do it something like that: e to the x cosine x minus e to the x sine x. You just split these two integrals like that, and if you just do by parts in one of these in one of these equations, let's say this, so you're gonna have a term like integral of e to the x sine of x dx, and maybe this and this becomes cancelled out. Well, I don't have solved, I haven't solved that, but it's important. Then you're gonna have some sort of this thing only, right? And well, I think you should just go with, just use by parts in it, okay? But I'm not doing that here because I have a very well known identity of integrals that I'm just writing over here, that says that integral of e to the x times f of x plus f dash x is just e to the x times f of x plus c. Again, this is a well-known property that saves your a lot of time, because if you go with that method that I just mentioned before, that is by parts, then you're gonna take a lot of time to solve this. But if you know this property, and that is why I just came up with basic integrals, because that allows us to understand how everything works. And these type of maybe if you're solving a very classic integral, then maybe this property is being used over there, but you don't know the property, and that's why you struck. Maybe it's something like that, so that's why. So yeah, we are just going to use. And well, if we just relate this with our integral, then our f of x equals cosine of x, and f dash x is minus sine of x. So well, this simplifies to, our integral simplifies to just e to the x cosine of x plus c. That's it. Yeah, so that's why it's very important to just do all the things like that. Okay, now we are heading towards another integral that says the integral of dx over sine squared of x cosine squared of x dx, right? Okay. At first it looks quite difficult because everything is just sitting in the denominator, and we're not having a proper information about the numerator. So that's what we are going to do in this integral, that we are just going to divide by cosine squared of x in the numerator and the denominator. So sine squared of x times cosine squared of x over cosine squared of x dx. So this becomes secant square of x, and we cannot sort this out something like that. I have to go further for this. And how I would, because let's say that I did that, okay, so I'm just having secant square of x in the numerator, but in the denominator I'm just getting cancelled out these two things, and I'm having the same result because I've just switched this up in the numerator as secant square of x and cosecant square of x. That's not good. So to get rid of that, I'm just going to do something great, and this is, I'm just dividing with cosine to the 4x, and same with the denominator, that is dividing with the cosine squared of 4x. So if you look closely, send cosine squared of x and this becomes cosine squared of x, and sine squared of x and cosine squared of x, well, it's being divided, so it becomes, well, in the numerator we are having secant to the 4x, sorry, and in the denominator we are having tangent square x dx, right? So yeah, I can look something in this integral, and maybe you can also. I can write secant square of x something like that times secant square of x over, I can write tangent square of x as it is. I'm gonna change that too. And secant square of x can be written as 1 plus tangent square of x, and 1 secant square of x is just left over there, and over tangent square of x. And now I hope you must have noticed something over here, that is, I'm just going to let tangent x equals t. So the derivative of tangent x is just secant square of x with dx. So this becomes the integral 1 plus t squared over t squared dt. How cool is that? 1 over tangent square plus 1 dt, and the integral of 1 over t squared is just negative 1 over t, and the integral of t, yeah, it's sort out to something like that, and we are just going to replace t with our assumption, that is the tangent x. So negative 1 upon tangent x plus tangent x plus c, right? So yeah, it also sorted out to like, I'm just writing over here, negative of cotangent of x plus tangent of x plus c. How cool is that, guys? Yeah, it was a good integral, I would say. And let me tell you, all these integrals are um like multiple choice question type integral, right? Okay, and now our next integral is, what was 4, now fifth is the integral from negative 1 to 1 of the modulus, the absolute part of x minus 2 over x minus 2 dx. Condition is x is not equal to 2, obviously, to make it possible. And now we are just going to use the absolute part, like, what do you call, identity, that says something like that, when x is less than 0, and positive x when x is greater than 0. Again, it needs to be remember, or it's need to be prioritized by you guys, okay? So again, I'm just breaking up this integral as from negative 1 to 1, and, well, sorry, from negative 1 to 0. Well, our integral is being wandering in negative parts, and the absolute part of x in negative part is negative x. So we are going to open this up with a negative sign, that is negative of x minus 2 over x minus 2 dx, and plus 0 to 1 positive part, so it would be opened with the positive sign, that is x minus 2 over x minus 2 dx. So far so good. And now this cancelled out, negative of x, that is going from negative 1 to 0, plus x, that is going from 0 to 1. If you simplify this, it becomes okay, so negative of 0 and negative of negative 1 plus 1 minus 0. So this becomes minus 1, and well, am I having some sort of problem with this? or am I going well? Mm, -1. I've just I think I haven't did any mistake, but then why I'm having trouble with the answer? I'm having 0, and that's not the answer at all. Um, Wait a second, guys. Let me just think about it. Yeah, guys, I got it. Well, I was just doing a little mistake that I was not wondering about. Let me tell you what's the mistake that I did. Well, in this, like in this bracket, in this square, or in this rectangle, in this box, maybe, I have assumed for x, not for x minus 2. So for that, let's just replace with x minus 2. So this becomes negative x for x minus 2 is less than 0, and positive x for x minus 2 is greater than 0. So if you just have a look at this, so this becomes negative x for x is less than 2, and our limits, that is 1 is less than 2. So it means that for this integral, this absolute value becomes negative, like it will be open with a negative sign only, and that's where I just got stuck. I'm sorry guys for that. So this becomes that integral from -1 to 1 of negative x minus 2 over x minus 2 dx, and this becomes negative x, that is being evaluated from -1 to 1, sorry. So negative of 1 and negative of 1, right? So this becomes negative of 2, that is negative 2. So yeah, that's what this like this integral says. And please guys, be aware of that. I'm really sorry that I did mistake over there. And now we are moving on the next question that we are going to perform. Well, it's kind of classic integral, that is like that can be seen everywhere, I think. Dx over sine of x minus a times sine of x minus b. Literally, I have seen this integral multiple times in my life, and I don't know what interesting about this integral is. Well, anyways, let's do this. At first, it looks very difficult, but you just have to do a simple thing. That is, let's talk about the arguments of both the sine functions, that is x minus b and x minus a and x minus b. If I'm subtracting both of them, let's say that x minus b is being subtracted with x minus a. So x minus b minus x plus a. So this becomes a minus b, right? And that's what we are going to do. So what we are going to do is, let's introduce sine of a minus b after multiplying and dividing with it in this integral. I would say this is the most basic way to solve this dx, right? And when you just solve this, 1 upon sine of x minus a times the integral, let's open it up, and well, I can write this thing as x minus b minus of x minus a. That's why I just introduced that thing. So let's just write this up, something like that: x minus b minus x minus a, right? Sine of x minus a times sine of x minus b dx. So far so good. It looks quite complicated, but anyways, let's do this. So let's use the formula for sine of a plus b, and I would write this down for you. Sine of a minus b is sine a cosine of b minus sine of b times cosine of a. Again, in a box for you all, because it's important to memorize it every time. So this becomes our integral sine of x. Oh well, what I did a mistake. I should have written over here as a minus b, I think. Sorry guys, a minus b, and our integral is a minus b times the integral. Let's open it up. So it's sine of x minus b cosine of x minus a minus sine of x minus b and sine of x minus a cosine of x minus b. That's how we can open this up. Sine a cos b minus sine b cos a. Yeah, that's good. And denominator as it is. And now we are just going to split this integral into two integrals further, as you have guessed, I think, till now, maybe. If not, don't worry, I'm here. Sine of x minus b cosine of x minus a over sine of, with the common denominator, that is this big stuff. Let me just put dx over here, and yeah, sine of x minus a cosine of x minus b over, let's put dx over here, sine of x minus a and cosine of x minus b, right? And now let me just check everything is going correct. Yeah, so good. So now I hope you must have noticed that this thing and this thing getting cancelled out, and this thing and this thing getting cancelled out. Oh well, oh sorry, again I did a mistake. This is not cosine actually, or let me just, yeah, this is sine, right? Now it's good. And this thing getting cancelled out. So far so good. And now let's just move further in our integral, that says sine of a minus b times the integral of cosine of x minus a upon sine of x minus b dx minus the integral cosine of x minus b over sine of x minus b. Did I make a mistake? X minus, yeah, okay. Oh my god, I'm going brutal. Let's just shift this sign with this, and that's where, yeah, I'm sorry guys, again I did a mistake. Yeah, and now it's good. So as we can see that, and now first of all, the derivative of sine is cosine of x, right? So argument doesn't matter with us because a is just a constant for both the integrals, and now we are just going to use that thing. So that says 1 over sine of a minus b, and this says that, like, let me just tell you here, the derivative of sine of x minus a is cosine of x minus a with dx. So this becomes ln of this thing, right? That's what we are going to do. Ln, let me just use a parenthesis, ln of sine of x minus a, and for the same thing with the second integral, that is ln of sine of x minus b. And now we are good to go for the final result that says 1 over sine of a minus b times the ln using the logarithmic property sine of x minus a over sine of x minus b plus c. How cool is that, guys? Literally, it took a quite long way to come across the real result. Okay, now I'm looking for another integral. Let's talk about this integral. It would be telling us to a property. It would be reflecting us a property. So we are going to solve this thing. Which question number is this? I think it's sixth. Yeah, this was sixth, and now we're heading towards seventh. So yeah, the integral is from a plus c to b plus c f of x dx. Now we are just going to tell about how the function would change if we take the limits as a and b. Like we are not having plus c in both the cases. How we are going to deal with that? Well, if we look closely, let's just I think replace with let's let x equals um let's x equals t plus, well, let me just tell you what we're going to do. We are just okay, let's say that x equals t plus c, right? Let me tell you how I'm talking about. Like, okay, if we replace the upper function, when you just plug b plus c on the place of x, and when you just calculate for t, well, what I'm talking about is b plus c is t plus c. So c is c and getting cancelled out, and t becomes c, like t becomes b, sorry. So t comes out to be b, right, for our upper limit, and same for the lower limit, t comes out to be a. So now and dt becomes dx becomes dt because c is a constant, so we don't care about that. So our integral becomes from a to b of f of x becomes, like, x is replaced with t plus c dt. And let's just change the index variable, that is t, with x. We don't care about the index variable as it is, and it is a definite integral. So this becomes f of x plus c times dx. Yeah, so that's what I'm talking about. Like, I was about to change the function with some other function, but I have to just disappear this thing and this thing to a and b respectively. So another we are having a identity like that says the integral from a plus c to b plus c. I think I should just move it a bit lower. Yeah, f of x dx, that sorts out to be the integral from a to b of f of x plus c dx. Another property, guys, another property. And well, believe me, guys, these things are very important for you to understand the advanced calculus or advanced integrals. Must you need to do this. Yeah, and now we're heading towards another integral. Okay, I think there are there are a lot of most really basic integrals. I'm not going to just talk about them in this because I don't want to waste your time, guys. Okay, so I'm having let's talk about this integral. Okay, so our integral says what it was eighth, right? So eighth integral says that integral from 0 to 1 e to the t over 1 plus t dt equals, it's given, okay. And what we are going to what we have to evaluate is, we have to talk about this integral from 0 to a of e to the t of 1 plus t whole squared. We have to evaluate this integral in terms of a, obviously. That is why it is given. Let's talk about this, guys. Let me just drink some water because I'm having quite trouble in just talking. Wait for a moment, guys. So yeah, guys, I just have a sip of water for hydration because I'm on the way to teach you a quite good things. Well, let's not go into that, but we are going to evaluate this integral. How would we do that? That's the question. Okay. Well, if we solve this integral with by parts, let's just solve it anyways. Even I'm just looking at this integral first time, so yeah. So I'm just using di method for my convenience. So I'm just differentiating one. What should I do? I think differentiating this thing would be better for me. So 1 over 1 plus t whole squared. So if we are going to differentiate like 1 over 1 plus t whole squared, well, I would say that 1 plus t to the whole minus 2, and if we take the derivative of that specific function, I think it's minus 2 and it's 1 plus t, right? And this becomes minus 2. I think no, it's not being sorted out. We have to integrate this anyways. I don't mind because e to the t is it's it is the only function that integral of e to the x dx equals the derivative of e to the x. How cool is that, guys? I'm literally surprised with that. Anyways, we have to just integrate it. 1 over 1 plus t squared dt. So if you integrate that, so integral 1 plus t whole to the minus 2 dt, so it becomes 1 plus t minus 2 plus 1. Oh, sorry, we have integrated this over minus 2 plus 1 plus c. So this becomes minus of 1 over 1 plus t, right? And that is quite relating with our given integral, I would say. Let's just keep wait a second, what happened? Wait a second, guys. Let me just move this a little bit here, and yeah, so this becomes negative 1 over 1 plus t. Wait a second, guys, my mom is calling me. Yeah, guys, actually my mom was calling me. That was urgent quite. Well, let's back to our integral. So yeah, and the derivative of e to the t is just e to the t. So this is something like that. Okay, so this integral becomes negative e to the t over 1 plus t and plus integral from 0 to 1, and integral from 0 to 1 of e to the t over 1 plus t dt. Well, we have done it, guys. This is given us to as a, and now we just have to evaluate this thing only. That's easy to evaluate. When you just plug t as 1, well, let's do that properly. E negative e upon 2 and plus e to the 0 1 and plus a. So this becomes a plus 1 minus e over 2. Yeah, so that is what this integral evaluates to. That is what our answer for that integral. Yeah, that is easy, guys. It's not that difficult, I think. But that was a fun. Okay, and now we are heading towards the second integral that says, let me just check it. The derivative of a function is given. Okay. Yeah, so this integral is going to be the last MCQ type integral. MCQ type integral, that is ninth number, and I'll take another one for 10th for your convenience. I don't mind. So the integral of secant x over secant x minus tangent x dx. Well, again, there are multiple ways to solve this, but I would go with a really different approach that would just end, that we would be ending up by vanishing the denominator forever. And how would it be working? Like, how would it be done? Well, the integral of secant x over secant x minus tangent x multiplying with secant x, I don't want to just compress it. Yes, so here it is, secant x minus tangent x, well, plus, sorry, and secant x plus tangent x. Why I did that, you will get to know in a while. So in the numerator we are having secant x times secant x plus tangent x, and in the denominator we are having secant squared of x minus tangent squared of x. That is just one. Again, how cool is that, guys? And well, I hope you know the property that says a minus b being multiplied with a plus b is a squared minus b squared. Yeah, if you're watching this video, you must have an idea about that, and if you don't have, please leave this video for now. Have your most basic things first and then just come back for this video. So this becomes secant squared of x minus secant x tangent x dx. So the integral of secant squared of x is just tangent x minus secant x plus c. Yeah, it was looking quite difficult, but again, it's very easy. It's literally very easy. And our 10th integral would be, let's which one should I introduce to you guys? There are quite okay. Let's talk about this integral. It looks quite good. 10th integral of tangent, like arctangent of square root of x dx. Whoa, that looks good. Let me just deal with yeah, I'm just gonna let root x equals t, like square root of x equals t, so x becomes t squared, so dx becomes 2t dt. So our integral becomes the tangent inverse of t times 2t dt. This becomes t times tangent inverse of t dt, with 2 being multiplied to whole things. Okay, and now what I'm going to do is to again use di method for by parts and differentiating what. Okay, how would I okay, let me jump. I'm just thinking about that. Differentiating tangent inverse of t, that is 1 plus t squared, and integral t squared over 2, right? Let's do that anyways, I don't mind. So this becomes this times this and this times this in an integral. So yeah, we come across with the t squared times arctangent of t over 2. Again, 2 is being multiplied to whole things, don't forget, guys. and with a minus 1 over 2 factored out with integral t squared over 1 plus t squared dt, right? And if we are just going to just multiply these two in these two terms, we are going to rid of all the half. So we are going to have t squared times tangent inverse of t over, oh sorry, it's not 2. And with let's talk about this integral, adding up 1 and just subtracting up 1 at the same time. So yeah, this is sorted out to t squared times arc tangent of t minus, I'm talking about this integral, so 1 plus t squared over 1 plus t squared minus, well, let's talk about dt, and minus dt over 1 plus t squared. So this becomes that t squared times tangent inverse of t minus, so far so good, this becomes like t, right? Because the integral of dt is just t, and this becomes arc tangent of t. And now we're having as t squared times arc tangent of t minus arc tangent of t plus t. Oh, I have to just change the signs because there is a negative just sitting outside it. So this becomes positive and then negative, right? And now our final step would be t is x squared, as we have assumed here. Sorry, it's not x squared, but it's square root of x. So t is, let's replace it with that. So this becomes x times tangent of square root of x plus tangent inverse of square root of x minus square root of x plus c, don't forget about that. And I think I did it, it's not wrong, I think. Yeah, you can just factor out tangent inverse of x from these two terms for the sake of better looking result. So that becomes x plus 1 minus square root of x, again plus c. So yeah, I have matched a result regarding this thing. Okay, so far we have done 10 what do you call it, 10 integrals that were quite basics, I would say. That wasn't tough, that wasn't moderate, but it was sitting in the range of moderate to easy. And now we're heading towards our second type of integrals. That's let me just talk about this. Okay, now we're heading towards conceptual type questions. Okay, let's talk about this integral. Now I'm just gonna draw a boundary here, because we have done the first type of integrals pretty far now. Yeah, now we are heading towards the second type of integrals, and these are not like these questions weren't asked in MCQ type questions. So yeah, so now first integral is dx over 9 plus 4x squared. Okay, now what we are going to do for this integral is well, okay, let me just talk about this. Okay, I got it. Factor out 4 from the denominator, so integral becomes dx over, I'm just factoring out 4, So it becomes 9 over 4 plus x squared. So far so good, guys. So this becomes 1 over 4 times the integral of dx over, well, I can write 9 and 4 with 3 over 2 whole squared plus x squared. Right, right, guys. And now this is a basic type of integral that says 1 over 3 over 2 times tangent inverse of 1 over 3 over 2 plus c. Well, it is going to just, it is finally evaluated to 1 over 6 times tangent inverse of 2 over 3 plus c. That wasn't really tough, it was really easy. Well, oh sorry, there was x, don't forget about that, x over, yeah. Okay, and now let's talk about, again I wouldn't be just, okay, let's talk about this thing. Okay, let's not talk about this thing, it's just basic. Well, I was just talking about this integral 2x over cube root of x squared plus 1. And till now, if you are watching this video continuously, you must have understood that what is the first step in this integral is, you just have to put x square plus 1. For your convenience, let us say that it is t cubed, and for my convenience I would say I wouldn't be let it to t, because it would be quite difficult to solve that. So 2x dx becomes 3t squared dt, and now our integral becomes 3t squared dt over the cube root of t cubed, and this is cancelled out, so integral becomes 3 times t squared over t dt. This becomes t 3t squared over 2. So 3 over 2, and t was, well, you can calculate 2t squared from this equation. That's it, guys, it wasn't tough. That's why I'm not talking about very easy integrals, but I'm talking about, okay, let's talk about this thing. Well, let's not talk about this thing. Again, this is very easy, right? Again, let me just introduce to the absolute part integral. That is the question number 2, and I just want to keep you in your mind, like, okay, and I want you to solve this integral by yourself. Literally, I would must say that don't watch my solution, because till now, as you remember, that the modulus or the absolute value of x is negative x for x less than 0 and positive x for x greater than 0. I have mentioned it in the video before some time. Okay, and now our function is x minus 5. So for that, let just replace that x with x minus 5. So this becomes minus x for minus x minus 5 for x minus 5 less than 0, and plus x minus 5 for x minus 5 greater than 0. And if you just calculate this thing, so this comes out to be x should be less than 5 for x minus 5, right? So if you look, though our integrals, like in the limits from 1 to 4, that 2 are in less than 5, so that is being opened with the integral from 1 to 4 of negative x minus 5, and that is really easy to evaluate. I'm not gonna just do it again, and this is maybe a homework for you guys. Tell me the answer for this integral in the comment section. Okay, now let's talk about a quite good thing, I would say a quite good. So third is the integral dx over the square root of 4x minus x squared, right? Okay, pause for a second, just think about how would you gonna deal with this. Again, everything is just sitting in the denominator, so it is quite difficult to do that at first. But anyways, let's try out some methods. Well, if you know what, guys, if I replace this x with 1, so this integral becomes dx over square root of x 4 minus x square. That is a very easy integral. There are some formulas for this also, but that is why we have introduced x over there, because everyone claims all the formulas, but no one claims how to solve these kind of integrals. Okay, let's do that. Okay, now um what we are going to do is, let's do that. So I'm just gonna do the integral over, let's factor out -1 inside this radical. So x square minus 4x. Oh, this is not t, this is x. So our integral becomes dx over the square root of minus of x squared. Well, I'm just gonna add plus 4 and subtract plus 4 at the same time. Why I did that? To make it a perfect square, right? Obviously. So integral dx over square root of negative times, if you look closely, these three things combine to form x minus 2 whole squared, and this is 2 whole squared, 2 squared obviously. So let's just write down these two things: x minus 2 whole squared minus 2 squared, and again just multiplying the negative sign that we have taken out earlier in the parenthesis, that says 2 squared minus x minus 2 whole squared. And now maybe you can have a better looking from now, because as it's a linear equation or linear function, so there is a property or there is a method to solve this, and that says the integral of 1 over a squared minus x squared dx is the sine inverse of x over a. Yeah, so that's what we are going to do. Well, you can just proceed with letting x minus 2 equals t, but it's just time waste. I think it's just a linear function and the derivative of minus 2 is just 0, so we don't mind, and we are just writing our result that says sine inverse of x minus 2 over 2 dx. Oh, sorry, it's not dx but it's plus c. Yeah, it was a quite good integral, because this kind of integrals, in this kind of integrals you just have to use what do you call it, like you have to make a perfect square for your result. Okay, now we are heading towards another integral. Again, I'm just gonna test you what this was. This is fourth integral, that is dx over x squared minus 6x plus 13. Okay, how we are gonna proceed with this integral? Again, we just have to think about something that makes it a perfect square, and we are having a lot of properties or formulas for perfect squares integral inside the denominator. Okay, okay. So if we look at this thing or this thing, let's talk about how we can make perfect square. X square minus 6x, Okay, and if we compare it with x square minus 2ax, let's say, and plus a squared for x plus a whole squared, oh sorry, x minus a whole squared. Okay, so 2 times a is 6, so a is 3. I hope you got an idea for this. So we are just going to have, like, we are just going to add 3 squared and again subtract it with 3 squared for our convenience. Or we can just think about this thing, like what I'm talking about is x square minus 6x plus 13 can be written as 9 plus 4, right? And now our integral becomes dx over x square minus 6x plus 3 squared and plus 2 squared. If you look closely, then this is a perfect square of x minus 3 whole squared of x minus 3. So dx over x minus 3 whole squared plus 2 squared. That is just the tangent inverse thing. That is 1 over 2 times tangent inverse of x minus 3 over 2 plus c. That's it. This is the answer for this integral, guys. Again, you just have to use this thing. You can compare it with that, or else, like, we have given 13 here. We have given 13 here. That is why we didn't introduce plus 3 squared or minus 3 squared. If it wasn't given over there, like the similar to this integral, we haven't given any 2 squared, so that is why we have introduced 2 plus 4 and minus 4, right? And if it had given plus 8, right, maybe something like that, I'm not sure, but yeah, you just have to use this thing. And you can calculate for a that you have to use for your for breaking this function into two squares. I hope you are learning a lot of things from my video. Okay, so I'm having another integral. It's quite easy, and I'm just going to tell you the way of doing it. I'm not going to do this. So the integral is 0 to 1 of x square e to the x dx. Just use 2 times by parts. Okay, and be sure that differentiating x square, or maybe 3 times that. Okay, let me just tell you what I'm talking about is di method. Plus minus plus x square e to the x e to the x e to the x. Integrating e to the x is just e to the x forever, and differentiating x square is 2x and x, oh sorry, it's 2. Again differentiating 2x, that comes out to be 2, and again minus, so the differentiation of 2 is 0, and the integral of e to the x is e to the x. And now alternative something like that. Just let me just tell you how it works. Multiply these two things. Again, keep remember the sign, okay? It should be just taking in the consideration. So let me just tell you, multiplying first with these two things, again multiplying these two things, adding up together these two things, adding up, and again lastly these two things, all these two things will be added up, and the last this thing, like I have represented it by dotted lines, so this comes out in an integral. The limits would be given for you, like for this integral it's from 0 to 1. That's how it works. Sorry guys. Yeah, that's how it works. That's it. You don't need to go quite deeper into it. It's not necessary for us, but I have told you a method to do. Well, there is another method that is just printed in our NCERT textbooks, that says the integral of f of x times g of x dx is the uh, f of x times the integral of g of x dx minus the integral of f of x times the derivative of sorry, yeah yeah g of x, no, um the derivative of f of x and times the integral of g of x dx, another dx outside this. It's a quite good result, but like in exams you have to use this formula only, but in solving daily problems you can use the famous di method. That is really relevant, or that is really convenient. Okay, and now let's talk about another thing. Well, okay, let's talk about this integral. I think in this integral we are again going to use by parts. um yeah, so what number of integral? Sixth integral is from 1 to 2 of 1 over x minus 1 over 2x squared times e to the x dx. Okay, so yeah, we are going to deal with this, and if we look closely, then let me just think about it. Okay. Okay, so in this integral, like we have already discussed, we are, let's just open it up. Let's just split this integral into two integrals, that is from 1 to 2 of e to the, well, it wasn't x here, it was 2x actually. Yep, so e to the 2x over x dx and minus integral 1/2 of integral from 1 to 2 of e to the 2x over 2x squared dx. Okay, in this integral let's use by parts. Okay, so let it using by parts in this integral, that is di method, plus minus. So the derivative of 1 over x and the integral of e to the 2x, 1 over 2 times e to the 2x, and it becomes, well, it becomes negative of 1 over x squared, I think. Yeah, that's good. So again, as you may remember, that these two things are getting multiplied to each other, and this inside an integral. So we comes out to be like, our result comes out to be 1 over e to the 2x over 2x evaluated from 1 to 2, and then it's negative times negative is positive, so positive integral of e to the 2x over 2x squared dx, and we were left with, let's put that in 1/2 inside the integral from 1 to 2, from 1 to 2 e to the 2x over 2x squared dx. Again, how cool is that this thing is getting cancelled out. We don't need to just care about these two things, we are just left with this thing. So when you just plug the limits, e to the 4 over 4 and minus e to the 2 over 2 plus, no, it's not c. So that is what we are evaluated to, that is what the answer is. Literally it was very cool, right guys? And now we're heading towards another question. Okay, now we are heading towards, I think, integration. Okay, I'm just finding some integrals, guys. Please wait. Okay, let's talk about this integral. We are just going to generalize this integral. This was seventh integral. This is seventh integral that says integral from 0 to 1 of x times 1 minus x to the n dx. So we are going to just generalize this integral, and this is a quite good. Like, if I'm talking about myself, I literally love generalization of integrals or any kind of summations also. I don't mind. So first step I would do is just replace 1 minus x with t. So x is 1 minus t, and limits would be going 1 becomes 0 and 0 becomes 1. Dx becomes negative times dt. Integral becomes from 1 to 0. X is 1 minus t times t to the n minus dt. So minus is helping us out with changing the limits, like respectively this becomes 0 to 1 of t to the n 1 minus t dt, right? Okay, and now what we are going to do is just nothing much, just multiplying this thing inside the parentheses and plus 1, right? I'm just multiplying this thing into these two things, like respectively. So this becomes the integral of t to the n is t to the n plus 1 over n plus 1 minus t to the n plus 2 over n plus 2, being evaluated from 0 to 1. So this becomes 1 over n plus 1 minus 1 over n plus 2. That's it. So that is our answer. We have evaluated, or we have generalized it, right? Let's talk about this integral. Now our eighth integral looks like this. Integral from negative pi over 4 to 0, 1 plus tangent x over 1 minus tangent x dx. Okay, how we are going to perform this thing? Okay, 1 plus tangent square is secant squared x. We don't care about that because we are having 1 minus tangent squared x in the denominator. So are we going to are we going to just replace x with well, let's do a very good thing for this integral, and I would say use this property that says from integral from a to b of f of x dx is the same as integral from a to b of f of a plus b minus x dx. A very well known property, a very well used property, and I would say that please remember this. This property is gonna helping us out in a very vast ways. And how we are going to use this property in this specific integral? Well, a is negative pi over 4 and b is 0. Just use that. And f of x, if you might know about that, but let me tell that also. I don't mind. So yeah, that's what we are going to use, that property. So becomes integral from negative pi over 4 to 0 of 1 plus tangent of 0 minus pi over 4 minus x over 1, sorry, minus tangent of 0 minus pi over 4 minus x dx. So integral from negative pi over 4 to 0. Oh, I'm sorry guys. 1 plus tangent of negative of pi over 4 plus x. 1 plus tangent of negative of pi over 4 plus x. So far so good guys. So integral from negative pi over 4 to 0, and well, you might know that tangent of minus x is minus of tangent x. So that's what we are going to use. 1 minus tangent of pi over 4 plus x over 1 plus, no, oh wait a second, yep, yeah, 1 plus tangent of pi over 4 plus x dx, right? So far so good. And I think we are going to just expand tangent of pi over 4 plus x. How are we going to do that? Obviously there is a formula for that, that says tangent of pi over 4 plus tangent of x over 1 minus tangent of pi over 4 times tangent of x. Am I right guys? Yeah, it's right, I think. Yep. So tangent of pi over 4 is 1 plus tangent of x over 1 minus tangent of x. So yeah, okay, and now we are going to just plug this thing over here. Integral from negative pi over 4 to 0 of 1 minus 1 plus tangent x over 1 minus tangent x over 1 plus tangent x over 1 minus tangent x dx, for the same denominator in both the ways, like 1 minus tangent x minus 1 plus tangent x over 1 minus tangent x, common denominator thing, again 1 minus tangent x and plus 1 plus tangent x over 1 minus tangent x. So we are getting rid of these two things, and this becomes from negative pi over 4 to 0 of 1 minus tangent x minus 1 plus tangent minus tangent x over 1 minus tangent x plus 1 minus tangent x dx. This becomes integral from negative pi over 4 to 0 of 1 and minus 1 getting cancelled out, minus 2 tangent x over tangent x and tangent x getting cancelled. Oh wait a second, okay, so it was a plus tangent x, so this is getting cancelled out, and 2 in the denominator. This becomes minus of integral from negative pi over 4 to 0 of tangent of x dx. So the integral of tangent x is I think it's ln of secant x plus tangent x. Wait a second guys, I'm just thinking about it. Ln of secant x, okay. So yeah, the integral of tangent x is ln of secant x, so this becomes negative ln of secant x from negative pi over 4 to 0. I think I did a I did somewhere mistakes. I'm having some sort of trouble with that. Or else should I continue? I think it's correct because ln 0 is I think 0. I think let me just check it right. Sorry, secant 0, not ln 0. So this becomes minus ln of secant 0 is 1 and plus ln of secant minus pi over 4, right? So this becomes 0 obviously, and ln of ln of secant minus pi over 4 is same as the secant of pi over 4, because there is no mean of negative or positive signs inside cosine or secant terms functions. That is why. So secant of pi over 4 is square root of 2. So this simplifies to square the 1 over 2 ln 2. So no, I didn't have any kind of mistake. I have done it correctly. So we have started from here itself and we are getting ended up here with a very better looking result. There are multiple ways of doing this. Maybe you can introduce secant x, something sort of like that, and you can proceed with that also. But yeah, I choose a long way to make you understand everything because I have used a lot of things here. That is, the first thing that we noticed here is this formula that I used, right? So yeah, it's necessary, guys. It's necessary to do basic integrals firstly before moving on to the classic integrals like Dirichlet. Well, let me tell you, I have just uploaded a Dirichlet integral solution on my YouTube channel. You should just check that out. And yeah, I have explained it in such a manner. Like I have used, I think, Feynman technique for that integral. That is really classic way to do integrals. The Feynman technique. Literally, believe me, guys. Okay. I'm having some sort of integrals. I can see it on my phone. Let's do that. Okay, so another integral is, let me just use this page instead. It was 8, so another integral is 9th. So 9th is the integral of e to the x times the square root of 1 plus sine of 2x over 1 plus cosine of 2x. Okay, guys. Okay. So now what we are going to do in this integral is, so yeah. Okay, let's solve this integral. Okay, so integral of e to the x times the square root of, well, one can be written as sine squared of x plus cosine squared of x plus sine 2x is 2 sine x times cosine x, right? And in the denominator I can use another property that says 1 plus cosine of 2x is 2 cosine squared of x. Again, a really important property. Please keep remember this property, guys, because literally I'm having a very brutal thing sitting on the in the denominator, but if I'm using this identity or if I'm using the formula, I got sorted out that thing. So 2 cosine squared of x dx. Okay, so integral becomes e to the x times The radical, inside the radical, we are having sine of x plus cosine of x whole squared. And 2, well, I can just factor out 2, I don't mind. Cosine squared x dx. So 1 over 2 factoring out as sitting outside the integral, along with sine x plus cosine x over cos squared of x dx. 1 over 2 times the integral of e to the x times sine of x over, should I do that? Okay, I can do that. Cosine squared of x plus cosine x over cosine squared of x right, dx. So 1 over 2 times the integral of e to the x over times this becomes tangent x secant x plus secant x dx, right? Okay. Again, as we have, like, as we started with this important identity, that integral of e to the x times f of x plus f dash x is dx is e to the x f of x plus c. Again, we are using that property for this thing. So the derivative of secant x is this, right over the setting right over there. So 1 over 2, so this integral comes out to be secant x plus c. That's it. That's it, guys. It was easy. It was literally easy. That's it. That is why I'm telling you guys, please just strong your basics, because just imagine if you are building if you are building a skyscraper, okay, but if the foundation of that skyscraper is not that strong, then how would it be shining in the world? Like, imagine, let's talk about a specific skyscraper. The longest skyscraper ever is Burj Khalifa, right? So if Burj Khalifa doesn't have a strong foundation, so it would have fallen till now. But because of its immense powerful foundation, it is standing at an immense height of around, I think, 856 meters or something like that. I'm not sure about that. So you just have to make sure that your foundation is best, and then only you can proceed in your life. That's what my motive is. Okay, let's talk about another integrals, and heading towards, I'm finding some sort of difficult integrals. E to the times sine of 2x. Should I introduce this integral to you guys? Okay, I'm just going to introduce this integral. We are going to solve ninth. This is 10th number integral. Integral of e to the x times sine of 2x dx. So yeah, if we are having something like this, like if we are having some sort of integral like this, we just have to use by parts. We don't have any kind of option rather than that. And I'm not talking about higher integrals. On the base level, we are just going to use this di method. I'm warning you guys, please don't use this method in your exams. It's not made for exams, otherwise you will not get any kind of marks. So use that basic method, like the integral of, well, I've just said earlier. So please use that thing also. I'm talking about India, but I'm not sure about other nations. But in India, we have to deal with that only. Okay, so the derivative of, well, both functions are like differentiable, or both functions are integrable, but which one should we take in our consideration? I think I should take sine 2x for differentiation and e to the x with integral. So 2, the derivative of sine is cosine of 2x. And if we again do that, plus the derivative of 2 cosine of 2x is 4 minus sine 2x, right? And e to the x as it is, we don't care. And now again, just this thing inside an integral, so this becomes that e to the, or sine of 2x times e to the x minus 2 times e to the x times cosine of 2x, and minus 4 times the integral of e to the x sine 2x dx. Well, let's say that this is I, so our I becomes this, and if you look closely, this is also I. So we are sorted out. I plus 4i equals e to the x sine 2x minus 2 e to the x cosine of 2x. Now I just becomes e to the x sine of 2x minus 2 e to the x cosine of 2x over 5. Right? That's it, guys. That's really it. That's it. This is the answer. And well, plus c, don't forget about that. Okay. Oh well. So do I take this in our consideration, or should I move? Okay. Let's take this. This looks quite complicated, but again, it's easy. So this is our 11th integral, I think. Yeah. 11th integral is, so the 11th integral is, this looks quite creepy, but don't be scared of it. 1 over square root of x times the square root of x plus 1 times the square root of x plus 2 dx. Right. Well, first step, maybe, well, if I would having only these two terms, or maybe these two terms, I would have just used this thing, like I'm just going to replace this one with square root of x plus 1 minus square root of x. That is a very simple life. But yeah, the question, the examiner, or the like the father of this question, have some sort of quite good brain, and yeah, he just played with that. So to just to remove any kind of term from the denominator, we just have to let square root of x equals t. Okay, so x square, oh sorry, x becomes t squared, dx becomes 2t dt, right? And dt, well, if I'm talking about if I'm talking about dt, let's talk about in here. So dt becomes dx over 2t, and t was square root of t, so dt becomes dx over, well, 2 dt becomes dx over square root of x. So now we're just going to replace this thing along with this thing with 2 dt. That is what really mathematics is all about here. Literally, it's love. Dt over t plus 1 times t plus 2. And again, the same method that I introduced earlier, in this integral only, that is t plus 2 minus t plus 1. If you look closely, you are going to have the same result in this case. If you just solve this thing, you're going to have 1. And now it's easy. I think it becomes ln of t plus 2 minus ln of t plus 1 plus c. Replace t with the square root of x plus 2 minus ln of the square root of x plus 1, or else ln of square root of x plus 2 over the square root of x plus 1 plus c. That's it. Okay, I think I messed up somewhere. I haven't looked at 2, but don't mind guys. Actually, I think this is correct. This is wrong, but the method would be same, right? The method would be exactly same. And yeah, I think you should just check that out. Just use the same method instead of just looking at this answer. I think it's wrong. And okay, let's talk about another thing that well, I'm having a good integral, like it's looking quite good, but I don't know about the reality of it. Let's talk about this even. Sine cubed x times cosine of x minus alpha. Okay, again we have to generalize this integral. And how we are gonna do that? Just wait for a second guys and just look at this integral. And till that time, let me just have a sip of water. Okay, so how we are gonna do that? Should we expand? Well, it is literally gonna complicated if I'm expanding cosine of, like, the term which is cosine of, oh well, do we need to do that? Okay, actually guys, we have to expand that because our life will be easier if we are expanding that integral, like, sorry, not integral, but the cosine of x minus alpha. Let's do that. So this becomes dx over square root of sine cubed of x times cosine of x times cosine of alpha plus sine of x times sine of alpha. This is the expansion of cosine of x minus alpha. So integral becomes dx over let's okay, let's factor out sine from this thing, like from this parenthesis. Let's factor out sine of x. So square root, this becomes sine to the 4x, and if you are factoring out sine x, then we have to divide sine x here. So to maintain that, I'm just gonna write cotangent of x. So cotangent of x times, cosine of alpha minus sine of alpha. And now this becomes that dx over the square root of sine to the 4x is just sine squared of x, and again we are having the square root of x with cotangent of x minus cos alpha minus sine alpha, right? So integral becomes cosecant squared x dx over square root of cotangent of alpha. Oh, guys, sorry, it is being multiplied to cosine alpha, right? So yeah. Oh my god, I messed up here. Cotangent of x times cos alpha minus sine alpha, right? And if we are just looking at this thing, let's say that cotangent of x times cosine of alpha minus sine of alpha is t. As sine of alpha and cosine of alpha is a constant, are constants, so the derivative of this thing is comes out to be cosine of alpha outside and negative cosecant squared of x dx becomes dt, right? So cosecant squared of x dx becomes negative dt over cosine of alpha. So integral becomes minus dt over cosine of alpha over, or else I should have taken this as t squared to just get rid of the radical. So our dt and all this stuff becomes 2t dt minus with a minus sign. So let me just replace with that 2t dt, and we are having t squared, so square root of t squared is just t and becomes 1 over cos alpha with minus 2 and times the integral of t over t dt. So this becomes minus 2 over cos alpha of t, and finally this becomes minus 2 over cos alpha. T was cotangent of x times cosine of alpha minus sine of alpha plus c. Well, this was a quite good integral. Yeah, literally this was a quite good, and along with the square root, guys, don't forget about that because we have assumed as t squared. So yeah, this was a really good integral. Like in this whole video, this integral was quite good because it looks really amazing at first, and at first, like, even I didn't recognize how to just deal with this at first. There are some sort of integrals that are quite good. Actually, I'm really sorry, guys. Actually, my sister just interrupted us. Okay, I hope you didn't mind. And now we're heading towards another integral. This is this 13th integral, and again this is a very general integral that we usually look after. Integral from 0 to pi over 4 of ln of 1 plus tangent x dx. I think I should just tell how to do this. I don't need to do that properly because I have used the method that we are going to use in this specific integral earlier in this video. So the method would be, step first is just use the formula for tangent of step first would be use this thing a to b f of x dx equals integral a to b f of a plus b minus x dx. Second would be tangent of pi over 4 minus x is 1 minus tangent of x upon 1 plus tangent of x, and you will get to have a very good, I think it's gonna be pi over 8 ln 2. Let me just think of it. Or pi over 4 ln 2 maybe. No, it's wait a second. Yeah, pi over 8 ln 2 is the answer. Okay, so yeah, I was right because I have done this integral a lot of time in my life. That's what. So if you just solve this using these two things, if you solve this integral, you're gonna have this result. That's easy to evaluate. I'm not gonna do that. Please, guys, do it by yourself. Okay, and now I'm having a quite better looking integral, and I don't know how to do that. Well, if I don't know how to do that, how would I explain it to you? I think I should just leave it. Well, please guys don't judge me. I'm just studying in class 12th, even though it's not just, yeah, I and these integrals are basics. I must know about this, but again, I'm not a master of integrals, and I'm having some sort of trouble in solving on difficult integrals, right? So yeah, let's move on to another integral that looks out. Okay, let's solve this integral, and with the help of this integral, I would explain you another formula for trigonometry. It's related to trigonometry. Okay, so I think it's 14th. Okay, so 14th integral is cosine of x over sine of 3x dx. Again, the formula for this is sine of 3x is 3 sine of x minus 4 sine cubed x. And when you just solve this, when you just use this thing in this integral, so and now you are having like degree 1 of sine terms, right? Like, sorry, not degree but argument of, like, single argument, that is x only. So just you can just plug sine of x equals t, and the derivative of sine of x is cosine of x, that is just appear in the denominator. So, and when after that you are gonna have dt over 3t squared minus 4t cubed, right? Sorry, 3t actually. So if you solve this integral, so how you gonna do that? 1 over t, factor out 1 over t, right? So 3 minus 4t squared. And again, I think you should just do it by completing the square method. Maybe I should tell this to you because it's kind of being complicated. Wait a second, guys. Let me just relax myself. Actually, I'm having trouble some sort of, but let me just have a relax for me, and you should also. But for you, it's just a 1 second gap. But for me, it's a 5 minute gap. Sorry, but we'll meet again, guys. I took a 5 minute break, 5 minutes of break, and I came back with this integral. And I was literally thinking of this integral like it was easy to evaluate. But when I'm thinking it deeply, or when I'm just imagining this integral in my head, I think it's not gonna be easy at all. And that is why I decided to do this integral on my own. So well, let's begin with. And we will be doing this integral in a very respectful manner. Okay, let's begin. So cosine of x dx over, using this formula, 3 sine of x minus 4 sine cubed of x. Just let sine of x be t, then cosine of x dx be dt. Okay, so now our integral becomes dt over 3t minus 4t cubed, and this is literally a beastie integral, I think. So we are going to evaluate this integral, and again I'm just going to factor t outside, and 3t minus 4t, oh sorry, again I just messed up, guys, because I don't usually make this long videos, like 1 hour 43 minutes or something, 44 minutes, something like that. That is why I'm sorry for that, guys. 3 minus 4t squared dt. Okay, t as it is, and factoring out 4 as 1 over 4, and this becomes 3 over 4 minus t squared, right? Or maybe we can factor out 1 over 4 minus 1 over 4 times the integral of 1 over t times t squared minus 3 over 4 dt, right? And so far so good, guys. It's not difficult. Matlab, like, sorry, I mean, till now it's not difficult, but it's literally not difficult, but it's kind of lengthy. Okay, it's just kind of lengthy, but it's not difficult at all. Okay, so minus 1 over 4 times the integral of 1 over t times t minus square root of 3 over 2 times t plus square root of 3 over 2, that can be factored out as this thing. Okay, so now our lengthy part begins from here. I mean, it's literally a lengthy because we are going to use, I don't know what we call that, like, I have forgotten that. Okay, it's all right. So yeah, so for this integral, let's use, I can just write this integral as, let me just copy it down slightly, and then yeah, a over t plus b over t minus square root of 3 over 2 and plus c over t plus square root of 3 over 2. That is what we are going to solve this equation for a, b and c, right? So if we just take the common like denominator, so this thing and this thing getting cancelled out, but I'm just stepping those two steps. Okay, I'm just stepping up two steps. Okay, so this becomes t minus square root of 3 over 2 times t plus square root of 3 over 2 b times t plus square root of 3 over 2 plus c times t minus square root of 3 over 2, right? So 1 becomes a t squared minus 3 over 4 plus b t squared plus t square root of 3 over 2 and plus c t squared minus t square root of 3 over 2. So just opening up all these three things, a t squared minus 3a over 4 plus bt squared plus bt square root of 3 over 2 plus ct squared minus ct square root of 3 over 2. And now we can do a plus b plus c with a common factor, that is t squared, and all the constant terms would be written like that. Yeah, so minus 3a over 4 and wait a second. Okay, plus 3t square root of 3 over 2. There was b, I think I've messed here, b, right? And minus ct square root of 3 over, well, it's b actually, I'm sorry, b, yeah, ct square root of 3 over 2. Okay, so a plus b plus c is 0. Okay, and well, if you look closely, this is the only constant term, and these two things are being factored out as t outside. So these two things are a factor or of t, and these three things are the factor of t squared, right? This means that this term is being equal to 1. That's what we are going to do. So 1 equals minus 3a over 4. So our a becomes negative 4 over 3, right? and b from here b plus c becomes 4 over 3, and from here onwards, if you are taking the consideration of these two equations or these two terms, then b times square root of 3. Oh, wait a second, I can factor out t times square root of 3 over 2 b minus c, and that is equal to 0. So it means that b minus c is equal to 0, right? So b equals c, right? So if I'm just plugging b equals c here, so it becomes 2b equals 4 over 3. So b equals 2 over 3, that is equal to c even also. So we have successfully evaluated our a, b and c, right? And now we are just going to do that in our integral. Put all the stuffs in our integral along with the negative 1 over 4 as a factor outside 4. So integral, so a was negative 4 over 3 over t. So negative 4 over 3 over t dt, I think I should use a big bracket here, plus b was 2 over 3, and that was t minus square root of 3 over 2 dt, and then plus the 2 over 3 over t plus square root of 3 over 2 dt, right? So this becomes negative 1 over 4 and negative 4 over 3 times ln of t plus 2 over 3 times ln of t minus square root of 3 over 2 plus 2 over 3 times ln of t plus square root of 3 over 2. Again, just multiplying the common factor inside the parentheses, we come across with 1 over 3 ln t minus 1 over 6, I think, ln of t minus square root of 3 over 2, and minus again 1 over 6 ln t minus plus square root of 3 over 2. And what we have assumed t as, t was sine of x, just replace it with that thing. So this becomes 1 over 3 ln of sine of x minus 1 over 6 ln of sine of x minus square root of 3 over 2 minus 1 over 6 ln of sine of x minus or plus square root of 3 over 2 plus c. This is what we are being evaluated to, and this is literally a very good result, I think, guys. Okay, when you just like these all things are in like ln terms, so you can just use the property of, I don't mind, like this is also correct, but if you use that thing to simplify it further, that would be great for expression. Okay, and now we are, I think it's 2 or less than 7 minutes remaining for. Okay, so now we are done with this integral, and now heading towards another integral that is also quite good looking, I think. Let me just tell you again of all this. So I think it was 14th integral, yeah. So this is 15th integral. Let me change the page even. So the integral is x squared times ln of x squared plus 1 dx. Okay, so let me tell you a very interesting thing. For any kind of integral that is consisting of x squared plus 1 type of term, in anywhere, it doesn't matter the place, like in the sorry, inside the denominator or inside a logarithmic term or inside a trigonometric function, I don't mind. Just use x equals tangent of theta. That's what we are going to do in this integral also. So this becomes, and dx becomes secant square theta d theta, right? So this becomes tangent square of theta times ln of tangent square theta plus 1 d theta. Sorry, secant square theta d theta. Secant square theta d theta. Tangent square theta times ln of secant square theta times secant square theta d theta. I hope you understand, like this is just a basic identity, that is this is equal to secant square of theta, right? Okay. Okay. Now what we should do is we can just do this thing, ln of secant theta times secant square theta d theta. So far so good. And now what should we do? Okay, so now we can we can proceed with di method, because these two things are integrable easily. I'm talking about these two things, and this thing is differentiable. So yeah, let's do that. Let's check whether we are wrong or right. I don't mind. I don't think so. I just do. So tangent square theta times secant square theta. So this becomes tangent cube theta over 3 if you integrate this, and this becomes secant theta tangent theta over secant theta, right? And this times this, and this should be in a integral. So this becomes that tangent cube theta over 3 times ln of secant theta minus the 1 over 3 factored out integral tangent to the 4 theta d theta. Well, whoa, how are we gonna do that? Tangent to the 4 theta is yeah, it's easy to evaluate that also, because we can write this as tangent square theta times tangent square theta, right? But then what? Okay, am I gonna just use secant square theta minus 1 on the place of tangent square theta, or something else? Let's think about this. Okay, let's do that anyways. Let's replace one of these two things with secant square theta minus 1. So this becomes that tangent cube theta times ln of secant theta over 3 minus 1 over 3 times the integral of tangent square theta times secant square theta minus 1 d theta. So this becomes tangent cube theta ln secant theta over 3 minus 1 over 3 times the integral tangent square theta secant square theta d theta, and plus 1 over 3 integral tangent square theta d theta. I hope you understood what I just did over here. I just broke up that integral into two integrals, right? And if you look closely, then this is what our I is, right? So in the next step, we are just going to send this thing on the left hand side, Okay, but how to deal with this? Let's just think about this. Okay, well, we know the integral of secant square theta, right? Well, this is I, right? Let's say that this was our, this integral was our I. Okay, so I plus 1 over 3 I becomes tangent cube theta ln of secant theta over 3 plus 1 over 3 times the integral of secant square theta minus 1 d theta. So this becomes that 4I over 3 equals tangent cube theta ln secant theta over 3 plus 1 over 3 integral secant square theta d theta minus 1 over 3 integral of d theta. So 4I over 3 becomes tangent cube theta ln secant theta over 3 plus the integral of secant square theta is just tangent theta over 3 and minus 1 over 3 times theta. Well, if you look closely, again you have to look closely, then 3 is just sitting common inside the denominator. We are getting rid of this, and our 4I becomes tangent cube theta ln secant theta plus tangent theta minus theta. So I becomes tangent cube theta ln secant theta plus tan theta minus theta over 4. What was our theta? Well, theta was tangent, like arc tangent of x. So I becomes, finally, let me just change the color. So finally I becomes, x was arc tangent of theta. Oh, sorry. Theta is arc tangent of x. So I becomes tangent of, well, if you solve this after just putting theta equals arc tangent of x, you're gonna have x cubed times ln of secant of arc tangent of x over, oh, not over actually, plus x and minus arc tangent of x over 4 plus c. Okay, so this is the value of this integral. Okay guys, it is really, I think, did I do a mistake? I think I did a mistake, guys. I don't know. I think I did a mistake in this integral, and I'm sorry guys, I cannot tell you the mistake that I did because I am f up. Like, I hope you understand what f means, because it's been 2 hours and 3 minutes. But please, I want you to solve this integral and do tell me the answer in the comment section correctly. So far we did a lot of integrals. I think it's more than 30, 35 or 40 type of integral. I think I hope you got to know a lot of things from this video, and I think I should just cut off right now because I am very tired. Okay, I'm not experienced of teaching this much hour. Okay, so thank you so much guys if you're watching this video, but please do let me know how would, what if you have any kind of recommendation for me. It would be a pleasure that you are recommending me something to improve myself. So thank you so much guys, please be supportive. I love you so much guys. Bye bye.